Are you ready? Here we go. Do you remember this guy here? That's our vertex form. What does that vertex form mean? That vertex form means that you're going to change this original graph somehow. Well, wait a second. Hold on, hold on. What was the original graph? The original graph is this guy. Remember? Your parabola. Yeah, that's that guy right here. There's your y-axis. There's your x-axis right here. Okay? The original parabola that would go right through this thing we call the origin, all the way down here, and look something like this, right? Well, we can't just be that simplistic. We're going to have to change this somehow. And this formula tells you all the different ways of changing this graph. Cool. So interpreting that formula, knowing what this formula is all about, is going to be really, really helpful and beneficial to us when we're looking at changing this graph. Now, we don't say we're going to change the graph. We actually use this wonderful word right here. We're going to transform the graph. That's what this means mathematically. Transform means change. Okay, so what does the A, P, and Q stand for? The A, you remember, is our stretched value. This is our factor of how much we're going to stretch the original graph. Our P is a horizontal movement. Now, how do you know this is horizontal? Why? Because it's with the X. X, if you think about it, there's your X. X goes this way, horizontal movement. The only thing that's left is the Q. And the Q is our vertical movement, here and here. Okay, is that all for the tricks? Not really. I'll give you a few more here. But now, look at this question. The question says, describe. That's the hardest part. They don't want you to draw this. Actually, if you were to draw this on an exam, or let's say a diploma exam or a district final exam, you won't get any credit for the drawing. Nothing, zero. You have to describe this using words. This is where understanding this formula right here is so incredibly important. Okay, let's go then. Let's talk about the A value first. And if you look at this question, the A value is right here. The A value will always be up front there. That A value is 2. What does that mean? What kind of transformation is that? Well, surprisingly enough, this is actually called a vertical stretch. And this would be of a factor of 2. What does that mean? That means every point on this original graph, this guy right here, this original, every point on this is going to be stretched vertically by 2. Now, here's the cool thing. Can you stretch a 0 by 2? 2 times 0 is still 0. So what you're going to get here is something that's really cool. This is all going to be stretched, but that original point is still going to stay there. See how that works? Isn't that cool? Okay, so look what happened to that graph. In fact, that graph became dun, da, 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 narrow. Isn't that neat? Okay, so let's go on to the next part. Here's the only tricky part. This part right here. Look at that. That value, that P value, is in fact 3. Now, you're probably saying, well, wait a second, there's a negative in front of it. Yeah, but so what? Look at this original formula. This original formula had a negative built in. So what does this mean? Check this out. I'm just going to look at this. I'll just look at the p-value only. If I'm looking at the p-value only, look at the original formula. It has a negative in it. If the p-value was a positive 3, would you not just substitute a positive 3 in there? And you would get, finished off, look at this, you'd get x minus 3 squared. But look at the original number. The original number was positive 3. Wait a second. But what happens if it's a negative then? Oh, well, check this out. Why, if your p is actually, let's say, a negative 2, check this out. This would be y equals to x minus, substitute in the negative 2. Look what happens. Negative makes this a positive, which is kind of looks like what we got right there, hey? Yeah, that's going to be the next question. So that's the only trick to this. You got to remember that if this guy is a negative, the p-value, in fact, is positive. Now, since it's with the x, and the x is in this direction, like this, we're talking about a horizontal movement. So this is actually called a horizontal. Now, they don't call it a horizontal movement. They actually call it a horizontal translation. Oh, is that not super cool? Yes, it's a horizontal translation. Now, describe it. This is going to be 3 units. And since this is positive, you're going to say it's 3 units right. Done. That's how simple this is. Okay, let's look at the last thing. This is our Q value we got to talk about. And here's our Q right there. There's our Q equals to +4. And I said before, since we're talking about the Q value, that guy is a vertical translation. And that's how you're going to describe it. This is a vertical translation 4 units up. And that's how you describe this entire thing. Look, we're describing all of the transformations of stretch, a vertical translation, and a horizontal translation. All of these 3 words are under this umbrella of transformations. Pretty cool, right? So let's go on to B. Now hold on a second. I'm just going to clean this up for you and we'll go on to B. Shazam! Okay, let's go. Here's the B value. There we go for question B. Look at the A. The A value now is a -1/2. Now, what does that describe? Okay, well, let's describe this then right now. What does the negative mean? The negative means, well, a lot of people refer to this as a flip. Technically, that's not right. If you go to a math party, for example, and they're talking about transformations of parabolas at this math party, and you've got all these people walking around going, oh yes, let's talk about the transformation of the parabolas in question here. Okay? And somebody says, oh, flip. They're going to look at you and go, flip? Oh, ew, no, it's not a flip. You actually call this, ready for this? This is technically called a reflection about, the x-axis. And it's so, and as a result, it's actually not just a reflection, it is a vertical reflection. So they're getting really, really specific about this. Now, you're probably saying, well, I don't get it. Well, think about it. If your parabola originally was here, and then you flipped it to look like this, what are you in fact doing? You're going and flipping this down here, flipping this to down here, over guess what axis? The x-axis. So in fact, it is a vertical, right, up-down movement, reflection about the x-axis. Oh my goodness. Now, if you do that, everybody at the math party will look at you and go, oh, I like this guy. He's very, very smart. Okay? Now that we've taken care of the negative here, right, let's talk about this half. Well, again, we call this a stretch. Okay? So this is a vertical stretch. Notice I'm using VS now. I'm going to start using some nice little abbreviations here so I don't have to write it all out again. But VS stands for vertical stretch about the x-axis again by a factor of 1/2. Oh my goodness, look at all the words that we use to describe. Isn't that interesting? Now, why is this so? Well, let's talk about this. Look, just like we talked about the last one, here's our original parabola right here. Now, take every one of these points right here and go by a half. So that point's now a half, that point's now a half, that point's now a half. Cut all of the vertical heights in half, except of course this one, because half of 0 is still 0. Look at the graph. Look at the graph. Look what's happening to it. It's becoming wider. Isn't that interesting? So in fact, when we vertical stretch by a factor of a half, we're in fact making this wider. Isn't that neat? Yes. Okay, now here we go. Start talking about the other things. See the x plus 5? Do you remember what we did last time? Think about this factor was y equals to x minus something squared, right? How do we make this into a positive? The way you make it into a positive is that the original is actually negative. There's your negative, negative, which makes this a positive. So your p-value then is actually -5, which if you remember, this is a translation and it's a horizontal one. So we're going to call it an HT, a horizontal translation of 5 units This would be left. Ta-da! And the last one then, okay, is this Q value, which is a -4. You can barely see it out there. There's our Q, is -4. Since this is a vertical translation, but how much? Well, 4 units. And which direction are you going in? Well, you're going down. That's what negative means. Are you getting this? I think so. So how about we do C, and we'll do this a lot quicker here. Okay, so I threw a bunch of tricks at you on C. Here we go. There's your A value. A value is 1/9. And maybe it might be an advantage here if you identify the A, P, and Q right away. So there's the A value, 1/2. There's the P value. Remember, that original one was supposed to be negative. Now it's a positive, meaning that this is a -6. And lo and behold, there's no Q value out here. Well, that means it's 0. So that means the Q value is 0. Now that we have identified the A, P, and Q, we can now describe it. Okay? Notice the A here. Remember, those are our vertical stretches. So this is a vertical stretch about the x-axis. Okay? Of a factor of 1/9, which means that this is going to be technically wide. Ta-da! There's our P, which is our horizontal translation. This will be 6 units, and since it's negative, this would be left. You got it. And the last one, of course, is going to be this Q of 0, which means that there is vertical translation. There is none. None at all. Okay? It's staying right on the axis. That's how you describe these. That's how you use your wonderful formula of the vertex method really, really incredibly well.